Welcome to absolute value transformations. This is where we're going to see the absolute value parent function shifted, stretched, and reflected, but still retaining its V shape. On every parent function, I start out with a transformation cheat sheet. Since our parent function is the absolute value, everything on here for f of x refers to the absolute value of x. So I'm going to give you an example of each one and what actually changes in these functions with the transformations. So my first one, f of x plus c. That is going to be like if I had y equals the absolute value of x plus, say, the number 2. That plus a number at the end means it goes up that much. That's the up. Now right underneath it, I have f of x minus c. That's like I had the absolute value of x minus a number, like say 3. If it's minus after the absolute value, that's going to move it down. Over to the other side, if I have the absolute value with f of x, but I have this plus inside the absolute value. This is what that would look like, be plus, let's say, 4. But it's inside the absolute value, that is going to be left. And the next one, if the absolute value inside has a minus a number, like minus 1 inside, that's going to be to the right. It's going to be moving your V up, down, left, or right. Now to the fun flipping them over. If there's a negative in front, that's like a negative in front of the absolute value. That's going to be a reflection over the x-axis. And if it has a negative inside the absolute value, like that, that's going to be a reflect over the y-axis. Now we have some stretching it might do. If the number in front of it like is greater than 1, so it'd be like y equals 2 times the absolute value, that's going to be a stretch by 2. It's going to make it taller. And then if it's a number between 0 and 1, so like a fraction or a decimal, that's going to be a shrink by whatever that number is. Another way to think of those is narrow and wider. Now I almost always don't use the one that's coming next, which is the C inside with the X. That would be something like, for C greater than 1, that'd be like y equals absolute value of 2x. And then the other one would be something like a fraction inside. I don't use those very often, but those are going to be horizontal stretches and shrinks. So the first one would be a stretch, but it would make it wider. And the second one would be a shrink, but it would make it narrower. And again, this is exactly opposite the one next to it, which is narrower and wider the other directions. I don't use that last one very often, but the others I'm going to use quite a bit in here. The ups and downs, lefts, rights, reflections and a little bit of these vertical stretches here on the left. And I will tell you, I'm going to do these in combinations today. So you're going to see more than one thing happening or more than one transformation in a problem. Here is the table filled out. All right, so here's our lovely absolute value parent function. Recall what he looked like. There he is, the nice V shape. He's got his little vertex right there at 0, 0. And that's what you want to concentrate on in all of these. You want to see how he looks. Also for stretches, if you notice each one of these, if you go up one, over one, for the slope, that is the normal parent function. That's not been stretched or shrank any, and you will be noticing that in the next few slides. Okay, so let's see a simple transformation. What happened in this one? So the first thing I notice is there's a +2, and it's at the end. Well, if the original parent function is the red one, because remember he starts here at 0, 0, and you look, up 1, up 2 to get the new one. Everybody moved up 2 points. So this guy is up 2. All right, let's see what happened in this parent function to get him transformed, because he had more than one thing happen. We notice there's a +2 at the end, and we notice there's a -3 inside the absolute value. So we got to figure out what happened with him. Now remember, our normal parent function is at 0, 0. So there he's at 0, 0. Well, I can already tell my guy has moved up 2 units. He's moved over also, but we can tell he's moved up at least 2. This part's the up 2. Now, I also notice from the little 0, 0, this guy moved over to the right, and it looks like he went to the right 3 units. So he went up 2 and right 3 in this graph. Or if you look at the equation, the +2 is at the end, so up 2. The -3 is inside, so right 3. Ooh, what happened to this guy? Well, we're going to start at one end. It looks like we have a +2 at the end. So we already know that that means something about this went up 2. Oh, look, he did go up 2. Now he's moved, but he did go up 2. Then we know the -3 inside. We know that said something about right 3. Look, he did go right 3. And then the most obvious one to us is that he's upside down. That negative says that he reflected over the x-axis. So he did 3 things. He's upside down, that's the reflection. See the V to the upside down V. He moved to the right 3 and up 2. All right, let's see what this one did. So I'm going to look at him. I've got an up 2. Which if I go from here, up 2, yeah, looks like he did go up 2. And I've got, according to this, a right 3. So if I go over to the right 1, 2, 3, yep, he's at the right 3. And then I look at the negative, made him turn upside down. Oh yeah, he is definitely reflected over the x-axis. And then there's one more little thing in there, that 4. The 4 makes him stretch or narrower by 4. So I'm going to look at that. Remember that slope thing I was talking about? Up 1 over 1 in the normal function? Well, let's see what he is now. Go up 1, 2, 3, 4 and over 1. 1, 2, 3, 4 and over 1. Oh my goodness, he's up 4 and over 1. So that makes that stretch by 4. So he's narrower. So again, he reflected, he stretched by 4. He's right 3 and up 2. All right, I want you to figure out everything that happened in this parent function. What all transformations did he do? So go to your interactive notebook over on the left side and answer this question. Make a quick sketch, write down the equation, and write down what transformations occurred in this parent function. And good luck.